Next, we are going to see chord of contact of a circle. The line joining the point of contacts of two tangents to a conic drawn from a point outside the conic. Here the conic is this is general statement. So we are seeing that the particular conic is circle, right? First conic section circle. This is the general definition for chord of contact. Is called chord of contact of the point with respect to the conic. Chord of contact of a circle. The line joining the point of contacts of two tangents to the circle drawn from a point outside the circle is called the chord of contact of the point with respect to the circle, right? Consider a circle with center C. Let P x1 y1 be any point outside the circle. Draw the tangent PA and PB from P to the given circle, right? So PA, PB, right, where A and B are point of contact of the tangent and the circle. Join AB, right? So the chord AB is called the chord of contact of the point P x1 y1 with respect to the circle. So right, so that is the AB is the chord of contact of the point P x1 y1, which is lying outside the circle. So we'll see the theorem to find the equation of the chord of contact, right? So we are going to find how to find the chord of contact of a circle. If P x1 y1 is the point outside the circle, x square plus y square plus 2gx plus 2fy plus c equal to 0, then the equation of the chord of contact of P with respect to the circle, given circle, is x into g plus x1 plus y into f plus y1 plus gx1 plus fy1 plus c equal to 0. Given circle is general form of the circle, right? X square plus y square plus 2gx plus 2fy plus c equal to 0. That is equation number 1. Let the tangent drawn from P x1 y1 touch the circle at a x2 y2 and b x3 y3, right? So this is the center P x1 y1 point lying outside the circle. So a x2 y2 and b x3 y3. So AB is the chord of contact. We know that the equation of the tangent at x1 y1 to the given circle 1 is x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. So the equation of the tangent at x2 y2, replace x1 y1 by x2 y2, right? So x2 plus y2 plus g x plus x2 plus f y plus y2 plus c equal to 0. So that is equation number 2. The equation of the tangent b x3 y3 to 1. So x3 plus y3 plus g into x plus x3 plus f into y plus y3 plus c equal to 0. Since the tangents 2 and 3 are passes through the point P x1 y1, so it will satisfy the equation. So x1 y1 satisfy the equation 2 and 3 because 2 and 3 are passes through P, because P is there, P is there, right? So instead of x you put x1 and y you put y1 in both the equations 2 and 3. So first put x is equal to x1 and y is equal to y1 in 2. So x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c equal to 0. That is equation number 4. Then put x is equal to x1 and y is equal to y1 in equation number 3. So x1 x3 plus y1 y3 plus g into x1 plus x3 plus f into y1 plus y3 plus c equal to 0. That is equation number 5. So clearly from 4 and 5, the points a x2 y2 and b x3 y3 satisfy the equation x1 plus y1 plus g x plus x1 plus f y plus y1 plus c equal to 0, right? So in 4 and 5, what is the common terms? Just to see the coefficients x1 y1, g x1 plus it will change, plus f y1 plus it will change, right, plus c is common. So changing point is x1. Next to x1 you are having x2 in the first equation. Next to y1 you are having y2 in the first equation, that is fourth equation. And in the fifth equation you are having next to x1 x3. So instead of x you can put x3 y3. So you will get the fifth equation in this equation, x1 plus y1 plus gx plus x1 plus f into y plus y1 plus c equal to 0. Put instead of x you put x2 and instead of y you put y2 in this equation, you will get equation 4. Instead of x you put x3 and y put y3, you will get equation 5, right? So that is x1 plus y1 plus gx plus gx1 plus fy plus fy1 plus c equal to 0. So grouping x term, y term and constant term, x into g plus x1 plus y into f plus y1 plus gx1 plus fy1 plus c equal to 0. That is equation number 6, which is the equation of a straight line because it is linear in xy, right? X term, y term, see the power is 1 only, that is why linear. Then remaining all real numbers, constants, right? Clearly the point a x2 y2 and b x3 y3 is satisfying the equation 6. Hence the equation of the chord AB is x into g plus x1 plus y into f plus y1 plus gx1 plus fy1 plus c equal to 0. Instead of this you can take as it is x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. Same equation both are, right? Note, if the point p x1 y1 is lying on the circle, right, circle 1, then the tangent itself can be considered as a chord of contact, right? If the point p x1 y1 is lying inside the circle, then there exists no chord of contact. Thanks.